Now let's go to the application 2, that is, which is a very important part of the combinations. That is, here the number of non-negative integral solutions, understand that please carefully, the number of non-negative integral solutions of x1 plus x2 plus x3 plus so on plus xr is equal to n is n plus r minus 1 c r minus 1. Next, number 2, the number of positive integral solutions of x1 plus x2 plus x3 plus so on plus xr is equal to n is n minus 1 c r minus 1. But before explaining that, let me first tell you the number of non-negative integral solutions means zero solution also included. The number of positive integral solutions means you have zero not included. Only positive integers should be taken. That means in the first case, it starts from 0, 1, 2, 3, 4, 5, so on. In the second case, 0 excluded. It starts from 1, 2, 3, 4, 5, 6. Okay. Now, for example, you went to a temple or any sacred place. You may be finding some 10 beggars outside the temple or outside the mosque or outside the church or outside the Gurudwara, whatever it is. And let us suppose there are 10 beggars and you have got some 8 coins in your hand. 8 coins in your hand. Then you want to distribute the coins to the beggars. Then in what way you do that? Just think of it. You may be thinking like this, or each beggar must be given 1. But there are 10 beggars and you have 8 coins in your hand, similar coins like 1 rupee coins, let me say. Then in such a case, you are distributing randomly. Then you may do like this. You can give all the 8 coins to a single beggar. And you may give 7 to one, 1 to other. You may give 6 to one and 2 to other. You may give 6 to one and 1 to one and 1 to third one. Then if you distribute like that, what about the remaining beggars? They will be getting 0 rupees. They will be getting 0 rupees. That means for this one, how the solution is in this case, how the distribution will be like, it starts from 0. One beggar is not getting any amount, then that means he is getting 0. And one beggar is getting 1 rupee. Let me say it is 1. One beggar is getting 2 rupees. It is 2. One beggar is getting, let me say, 3 rupees. Then it is 3. Then what should be the maximum value? It should be 8 only. If you give all the coins to a single beggar, he will be getting 8 rupees. That means the distribution takes place like this. Either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. It is nothing but the distribution of similar coins. Understand that? Okay. Now, let us take an example for that one for your better understanding without applying that formula so that you will better understand what should be done while attempting such type of problems. Let me say x1 plus x2 is equal to some 10. It's an algebraic equation. Now, I want to write the number of non-negative integral solutions. Then I'll start like this, 0, 10. It's one solution. 0 plus 10 is 10 only. It is 1, 9. It is also 10. 2, 8. 3, 7. 4, 6. 5, 5. Next, it goes like this. This will come this side, this will come this side. Understand? Just they will be interchanged. So what should be this one? 6. Next 4 and 7, 3, 8, 2, 9, 1, and it is 10, 0. So how many positive integral solutions do you have? How many non-negative integral solutions do you have? Non-negative matlab 0 also included. Non-negative in this case, or you can understand 11. And positive integral solutions in this case are excluding 0. These are only 10. Understand please carefully. Now, this is with all common sense. Everyone can do this, but we need an application in the combination. Then I'll do like this. How many are there here? 10. And how many variables are here? 2. So 10 plus 2 minus 1. C 2 minus 1. Then how do you write this, sir? How do we understand this? I'll explain you that. I'll explain it. Just wait. And this is 10. 10 can be written like this. 11 minus 1. This is, count this. 1, 2, 3, 4, 5, 6, 7, 8, 9 are there. Not 10. 9 are there. 9. So I'll write this in this way. 10 minus 1 C 2 minus 1. Understand it? Understand it carefully. This is 12 minus 1, 11. 11 C1. 11 C1 is nothing but 11 only. And here 10 minus 1, 9 C1 is nothing but 9 only. Do you understand? So if I give you a general equation like this, x1 plus x2 plus x3 plus so on plus xr is equal to n, you need the number of non-negative integral solutions. Non-negative means 0 included. In place of 10 you have n. In place of 10 you have n. In place of 2 you have r minus 1 c 2 minus 1. This is 2, this is r. This is r minus 1. Number of non-negative integral solutions. Next, positive integral solution from this one. Positive integral solutions. In this case, it is 10 minus 1. It is 10. It is n. It should be n minus 1. C. It is 2 minus 1. 2 minus 1. It is r minus 1. Then you may simply think like that. Sir, you are making it some magic here with the numbers and all. But you have the derivation for this one and you can derive this using binomial theorem. You can derive this using binomial theorem and we have to find out the coefficients there in the binomial expansion. For that one, we need the knowledge of binomial expansions, and whenever we start that topic, binomial theorem, then again we will discuss how these are derived and how that can be applied to the combinations at the time we will discuss. But for the moment, we are mainly focusing on JEE main, wherein you will be getting some straight questions like this. Then for those questions, this will be useful. So understand, please, the number of non-negative integral solutions includes 0 is nothing but n plus r minus 1 c r minus 1. Here r terms are there, here n terms are there. Sum of all this is n. Like what? There are 10 beggars and you have 8 coins only. 10 beggars, you have 8 coins only. That means if you add all the coins with the beggars, then you'll be getting the number of coins. Like that. So, similarly, here positive integral solution is n minus 1 c r minus 1. So, you can better understand this whenever you do not understand this type of things. You take an example and think of yourself. Then your logical thinking will be improved. Let's see a problem on this one. If you see, the first problem there. The number of integers x, y, z, w such that x plus y plus z plus w is equal to 20 such that x, y, z, w is greater than or equal to minus 1. Now, if you say this carefully, x1 plus x2 plus x3 plus x4 is equal to 20. And if you want to apply that non-negative integral solutions or positive integral solutions It's not possible because x may be -1, y may be -1, z may be -1, w may be -1. To apply that formula, it must start either with 0 or with 1. Understand? Either with 0 or with 1, but it starts from -1. So let us make a little modification like this. What we do now we will get this to other side. Then what will you get? X plus 1 comma y plus 1 comma z plus 1 comma w plus 1 in this case is greater than or equal to 0. Understand this please carefully. Understand this. So to apply that formula comfortably, the restriction to be fulfilled is it must start with 0. So if it is x, then we cannot apply that because x is greater than or equal to -1. If it is x plus 1, we can comfortably apply because it starts from 0. So what I do now, I'll add 1 to each of the terms. Then what happens? That becomes x plus 1 plus y plus 1 plus z plus 1 plus w plus 1. 4 added on left hand side, that is why on right hand side also 4 is added. It is equal to 24. Now you can consider this as x1 plus x2 plus x3 plus x4 is equal to 24. Now your common sense works out here. What does it mean? Whether to write non-negative solutions, non-negative integral solutions or positive integral solutions. Non-negative integral solutions or positive integral solutions. You can understand. Non-negative integral solutions means it must start with 0. So it should be the formula n plus r minus 1 c r minus 1. What is n here? It is 24. What is r here? 4 minus 1 c r 4 minus 1. It is 3. So it is 27C3. It is 27C3. If you simplify this, you'll be getting 27C3 is the answer. Fourth option, you can clearly see that. So whenever the direct problem is not given, direct application of the formula is not given, you have to modify like this. And of course, these problems can be solved using the coefficients also, where we need the knowledge of binomial theorem, their expansion and collecting their coefficients, all this we need. Okay, now coming to the next problem, the number of ways of selecting 10 balls out of an unlimited number of white, red, green and blue balls. So when you go through such problem, you will literally be confused because in the question, it is given that unlimited number of balls are there. Unlimited number of white, red, green and blue balls are there. Then you may be literally confused. Unlimited number of balls are there. How to choose 10 balls out of them and how many number of ways we can select 10 balls from them. But we have to take only the category here. What is the category here? White balls and red balls, then green balls, then blue balls, and totally there must be 10. Totally there must be 10. So white plus red plus green plus blue is equal to 10 now. Now apply the formula. It is x1 plus x2 plus x3 plus x4. In this case it's 10. And whether to apply a positive integral solution or non-negative integral solution, it is your common sense. No restriction is given there. No restriction means you can take all white balls, all red balls, all green balls, all black, all blue balls, isn't it? Now if you take all white balls, these will be zeros. If you take all red balls, remaining will be zeros. If you take 9 white balls and 1 red ball, then these two will be 0. If you take 8 white balls and 1 red ball, 1 green ball, then this will be 0. That means 0 solution also included. That's what I mean to say here. I want to make you understand that zero solution also included. Zero solution also included means it is nothing but n plus r minus 1 cr minus 1. Understand that, please. Now, what is n here? 10 plus 4 minus 1 c4 minus 1, which is nothing but 14 minus 1 13 c3, which can be simplified to be 12 into 13 into 12 into 11 upon 3 into 2, which is 2 times, and it is 13 into 22. If you simplify that, 26 plus 228, 286 should be your answer. Fourth option.